We're going to start our new unit today called Uniform Circular Motion. We talked a little bit about it the other day after we reviewed for our test. Uniform circular motion involves objects that are moving in a circle, so going around in a circle at a constant speed. That's the idea behind this uniform, constant speed. Now, as I told you the other day, that's a good approximation for a lot of things that exist out there in the world, a lot of real world applications. For some things, it's not. For some things that are speeding up dramatically going around a circle, this analysis won't apply. Okay? This applies when the object is moving at a constant speed or pretty close to a constant speed. There's a few terms that we have to define before we go any further, just like we do at the beginning of pretty much any unit. The first term is frequency. You guys have all heard that word before, right? Who has an idea as to maybe what frequency means? Think of it in the context of a sentence. Where have you heard that word before? Give me a sentence involving frequency. I'm sorry? Okay, sound frequency, all right? The frequency at which this occurs. Okay, the frequency. What's the frequency of Hat Day at HTA? Last Friday of every month? Once a month, right? Once a month. What's the frequency of Christmas Day? Once per year, right? Okay. What's the frequency of school? 5 times, usually 5 times per week. If there's a holiday, the frequency becomes 4 times per week. The frequency of something is how much it happens, how many happens per unit time. So how many times per week we have school? How many times per week we have school? How many times per year we have Christmas? How many times per month we have Hat Day? The frequency is the number of events that take place per unit time. Well, we're going to get a little bit more precise with that. We're going to say it's the number of cycles of something per unit time. We'll write down a little equation, although this equation isn't on your data sheet because it's more related to the definition than it is an equation. F is equal to the number of cycles over the amount of time. Does anybody want to take a stab at what the units might be for this? Number of cycles per unit time? At least the typical units. We have Hat days per month, school days per week, Christmases per year. We can have a whole bunch of different units. But what do you think the typical units would be? Right? No, actually it's not. RPM is a good guess because you do see that quite often actually, but that's not the standard unit for frequency. RPM, by the way, stands for revolutions per minute, right? Revolutions per second, or let's just say cycles per second. The same thing as a cycle per second would be a hertz. You ever heard that? You tune your radio. Maybe you tune it to 960 MHz, 960 megahertz. If you want to watch, or if you want to listen to the hockey game on the radio, that's where you'll tune it to, 960 megahertz. That's the frequency of that radio station. That radio station broadcasts that many radio waves per second. 1 hertz is a cycle per second. A megahertz is a million cycles per second. 960 megahertz is 960 million cycles per second. Period is real closely related to frequency, but not the same thing. The period is in fact the inverse of the frequency. It's the time per cycle. The amount of time that it takes to complete 1 cycle. So instead of saying for period, it's number of cycles over time, we're going to say for period, it's time over number of cycles. The symbol for period is going to be a capital T. Be careful with this one. Don't make it a lowercase t. Lowercase t is time, so is capital T. But lowercase t is any time. Capital T is specifically the time for 1 complete cycle. What do you think the units for that would be? The time for one complete cycle. Usually it's going to be seconds, right? Time for one complete cycle. Now we can use other units sometimes too. What's the period for the Earth revolving around the sun? 1 year. What's the period of the moon revolving around the Earth? 28 days. There can be period measured in other units other than seconds, but the typical, at least the standard units that we use to measure period is going to be in seconds. Speed. Well, we know what speed is, right? Speed is intuitive, how fast something's moving. But in this context, we're talking about how fast something's moving as it goes around a circle. As I swing my keys around my head right now, how fast are my keys going around my head? What's the speed of those keys? We know that since we're talking about uniform circular motion, we can describe that by the equation v is equal to delta d over delta t. An object going at a constant speed can be described by the equation d over t. Now pay really close attention to what I'm about to say here, or at least what I'm about to ask you. What is the distance? What is the distance covered by these keys as they go around my head one time? What's that called? Circumference of a circle, right? What's the equation for the circumference of a circle? Everybody gets this one mixed up. I always used to get this mixed up when I was your age. It wasn't until I was much older than you that all of a sudden one day I had an epiphany. Wait a second, that's how I can remember. What is the equation for the circumference of a circle? Pi times d, good, pi times diameter, or 2 pi r. Hey, what's the other one that people get mixed up with? Pi r squared, right? I always used to get those mixed up. How do I keep them straight now? Well, I'm not going to get a unit that's m squared, meters squared for circumference. That's a distance, right? But if I go pi r squared, my units are going to be meters squared. Meters squared gives me what? Area. So pi r squared is going to be the area of a circle. 2 pi r, or pi times d, is going to be the circumference of a circle. Jazzy, you said pi times d. I'm going to go with 2 pi r, only because that's the way that it's written on your data sheet. But in the end, if you want to write pi times d, it's the same thing. 2 times the radius is, of course, the diameter. All right, so that's the distance around a circle one time. What's the time that it takes to go around the circle once? We don't know what the exact value of that time is, right? But we do know a variable to describe that. What is it? The period, good. So let's say the speed of the object going around a circle is 2 pi times r divided by the period. Unfortunately, this is the only equation that you see written up here right now that's on your data sheet. The first two, F is equal to number of cycles per time, T is equal to time over number of cycles, they're just definitions. We do see one more actually that relates T to F. Since they're the inverse of one another, we can write T is equal to 1 over F, and that also appears on your data sheet. V equals D over T obviously appears there, and so does V is equal to 2 pi R over T, specific to an object going around in a circle at a uniform speed, at a constant speed. That makes sense? So we're going to go a lot further than that in this unit, obviously, but this is the basis of everything that we do in this unit, and largely the basis of a lot of the stuff we're going to do on our field trip at the end of this month. There's a lot of circle stuff that we do on our field trip to West Edmonton Mall at the end of this month. Roller coasters going around in circles, little things, little carts on certain rides spinning in circles, and so on and so on and so on. This is the basis behind all of that. Okay, frequency, period, and speed. Let's take a quick look at a simple, I think, quick problem. The hard drive in a computer, it has a diagram of it, but we don't need that diagram. The hard drive in a computer stores data on a thin magnetic platter that spins at a high speed. The platter makes one complete revolution in 0.00833 seconds. What's its frequency in hertz and in RPMs? What does RPM stand for again? Good, revolutions per minute. So let's get it in hertz first. What's a hertz the same as? Not a revolution per minute, but rather a revolution per, right. So let's get it in hertz. This is what? It's a time, yes, but specifically it's the the period, the time for one complete revolution. If I want to find the frequency, then I can simply say F is equal to 1 over T. 1 over 0.00833 seconds. I get 120.048 hertz. I'm gonna round that to 120 hertz, but I'm going to keep the unrounded number there as well because I have to convert the unrounded number to revolutions per minute. Now, I'm going to multiply or divide by something. Which is it? 60 seconds in a minute. So my number is going to be 60. Multiply by 60, divide by 60. Which is it? Yeah. Multiply by 60. Listen, I'm not afraid to tell you guys where my weaknesses is. One of my weaknesses has always been, I'm not nearly as bad at it now as I used to be, but still a little bit of this, still have a little bit of this weakness. I was terrible at things like this when I was your age. Do I multiply or divide? I always knew there was 60 seconds in a minute. Okay, but do I multiply by 60 to get the number of revolutions per minute, or do I divide by 60 to get the number of revolutions per minute? You know what I always ended up doing? I would always guess. I would guess. Simple as that. I would guess. But I was also smart enough to check my guess. Wasn't smart enough to be able to know ahead of time what I should do, multiply or divide, but I was smart enough when I guessed to check my guess. Okay, if I get 120 revolutions in a second and I divide it by 60, what am I going to get? 2, right? Does it make sense? If it spins 120 times in 1 second, does it make sense that it'll spin twice in 1 minute? No, it doesn't, right? Okay, we're all smart enough to recognize that. We may not know whether we multiply or whether we divide, but if we guess and we guess wrong, we should be able to catch that. Let's multiply it by 60 now. 120 times 60 gives me 7,200. 7,200 revolutions per minute. Does that sound more realistic? If it spins 120 times in 1 second, it's going to spin a lot of times in 1 minute, right? 7,200 makes a lot more sense than 2 does. Well, that's a lightning fast introduction to circular motion, to uniform circular motion. I'm going to have you do just a couple of questions, 3 questions actually for homework. They're going to go ridiculously fast for you. Also remember that you have your lab to do for Thursday, so 2 days from now. We'll check this stuff over tomorrow and collect those labs on Thursday.